There we go. We're live.
Perfect.
Woo.
And thanks for changing the time and being willing to do it this early and stuff.
No problem. Pretty much, we're getting so late in the semester that all my other groups have stopped meeting.
Really?
Yeah, one of them, our last meeting was last week 10. And then we were supposed to meet week 10 for one class, but our teacher's like, not feeling it. I'm just going to cancel the meeting. And we're like, okay.
That's nice.
Yeah, so we don't have to meet in that class anymore. So I really don't mind, and I didn't have to work today. I have to work tomorrow, but I didn't have to work today, so.
Oh, good.
So, yeah. Okay, well, let me rephrase that. I have to work my part-time job today, but that's only an hour and a half every day. So, I work kitchen tomorrow at the high school.
Okay, nice. And then what's your other one?
I teach part-time.
Really? That's awesome.
I teach, it's called digital art, but it's more kind of digital applications to sixth graders.
Interesting.
Mm-hmm.
Let's see. Who said the prayer last time?
I'm not sure we did one last time, so I'll just go ahead and say it.
Okay, thanks.
So, Heavenly Father, we're grateful that we are able to meet together to help each other learn and to move forward in this class. We're grateful for the guidance and hope that as we move forward, we'll be able to get the answers that we need, both for this class and for personal, that we will be able to accomplish this. And I say things in the name of Jesus Christ. Amen.
Amen. Okay.
Cool.
So, starting on the first one. For like the lesson 1 and 2 and week 4, the team discussion, like what is a vector and how do you find the components with this certain stuff. And so vector is a quantity with direction and magnitude, and the component form is like if you have like an A and B, it's the second x value minus the first x value, and same with the y's. And then to do it reverse, you just like it's the change in the x and y values. And then addition and subtraction, I mean, you just do exactly that with the different components. And then there's the scalar multiplication.
That one took me a second, but once I understood what it was easy.
And that just changes like the magnitude. And the dot product, it's multiplication. It's
multiply like terms and then add together.
Yeah. And the angle between two vectors, that's something I'm having trouble with still. Getting.
I had that here. Hold on a second.
And the direction too. Like I don't know. Are those the same thing? I just like I understand magnitude. It's just I couldn't find anywhere in the reading where it was, talked about the direction. So
the direction is going to be like when you figure out. Oh, sorry.
No worries.
When you've got your magnitude and you know that and you find that coordinate pair, it's basically whatever the degrees are is going to be what direction it is. So like if it's 135, it's going to be, if we start our flat x, 0 and then go 135, it'll be pointing that way into quadrant 2.
Okay. That makes sense. And then, like, I don't know, we don't need to go over it, but just how to find that is what I'm struggling with. Is it the
Yeah, that's what I'm looking through my
cosine?
notes for.
Yeah.
Okay. How we find that is you take, if you're given the rectangular coordinates, you can find the angle. I'm not quite sure how to do it with R.
Yeah.
Of course, if you...
I could, I mean, like, I don't want to take a bunch of time in the meeting to like learn it, but
Yeah. Oh,
like,
I just don't want to be hanging for the exam, though.
yeah, that's true. But I've got a 14-hour drive ahead of me today with my
Okay.
family, so I could have lots of time to study it.
True.
So,
Can I still just give you a really, really quick rundown? Because I've got a problem
yeah,
here that
yeah,
shows it pretty well.
yeah. Okay,
Okay. So
thanks.
it's the coordinates -3, 6 are the rectangular coordinates.
Okay.
And so we know that r squared equals x squared plus y squared.
Mm-hmm.
So you'll just go ahead and square the two coordinates. So you'll get 9, 36, add them together.
Okay.
It's
I've
a
been
lot like
doing that with
Pythagorean.
other ones, and other problems. They just, I guess, maybe use different terminology, or maybe it is a different thing, but
Yeah.
that makes
So that's
sense.
how that's how you figure out the r. And then to figure
Oh,
out the degrees, it's the arctangent of your y over your x.
oh yeah. Isn't that going from the different planes though?
What do you mean?
Like when you go from a Cartesian plane to a polar plane, isn't that just how you find the x and y? Or is that the direction?
That's how you find the degrees, and then with the degrees, you can figure out the direction. So this is taking it from the rectangular, the Cartesian,
Yeah.
into the polar. Because with
Okay.
our polar coordinates, we need our r, comma, our degrees.
Okay. Oh, I see. Yeah.
So anyway, when you take the arctangent, it's going to be a negative. So you'll add 180 degrees to it, and that'll give you,
Okay. I kind of
just
remember
skipping a
that.
few steps. Yeah, just skipping a few steps, you get 116.57.
Mm.
And so it'll be your
Okay.
r, which is 3 square roots of 5, comma, your degrees.
All right. Thank you.
No problem.
Let's see. Number 2. What are we on?
Which is actually number 6 that we were supposed to go over
Yeah.
in question 3. So that works.
Yeah. Um, excuse me. Um, yeah, so it's asking about the polar plane. It's just a circle.
Yeah,
And you already know that. I'm just checking off boxes.
that's fine.
So we did number 6. Discuss your solutions for converting between the planes. Um, for the first one, I got, yeah, I just got everything that was in the answer key, like the answers that they got. I
Okay.
just put it in my calculator. It's really
Okay.
easy. So
Yeah,
no problems there.
yeah, Going from polar to rectangle is a lot easier than going from rectangle to polar.
Yeah. I don't know. There's confusing anyways. So are we good to go on the extension problems?
Mhm.
Okay. Um so for the resultant vector, you isn't it basically the Pythagorean theorem, like a plus b, and then like it's that gives you the resultant vector?
I think. I
Yeah.
think
I mean
that
that's what it
was.
said in the reading and stuff like that.
Yeah.
So it's like that one. So real simple. Number two is when I had problem
Okay.
like understanding it, or like it's like this kind of problem that's like the same on the group quiz that I couldn't figure out quite by myself. So
Okay. So at this point, we'd be doing the parallelogram. I'm gonna pretend that's even close to parallel in the same size. So we know that one of them is pulling at a magnet of 200 pounds, and that the other one is 300 pounds. We know that the angle between them is 65 degrees. We know that the opposite angle would be 65 degrees.
okay.
Um, so 65 plus 65 is 130. So 360 minus 130 is going to give us 230. Divide that by 2 is 115 degrees, which that'll give us our big angles. And then we will divide that in half. And then, so what is 65 divided by 2? 32.5 will be each of the smaller angles. And then from there, I believe we can do the trigonomic identities, since we know that one side is 300, one side is 200, our large angle is 115, and our small angles are 32.5.
Do you have that written down? Like, could you show me which small angles you're talking about?
Yeah. Hopefully my camera won't. Okay. Here we go. So when you make the parallelogram, everything will be opposite.
Okay. So, okay. I see. So that's 115.
Mm-hmm.
Sweet, thank you.
No problem. So yeah, and then we can just do trigonomic functions, which I believe we're gonna want to do.
See, I have it
Opposite.
written down. Oh, would you not use like the sine, or I mean the like angle side, or like one of those things with sine and cosine, or
Yes. I'm just trying to think of which ratio would be best to figure that out.
okay.
Sorry. Opposite over adjacent. Maybe. Which one would be opposite? Which one would be adjacent? Oh, of course it could be. Brain, please work. I'm sorry, it's really early in the morning for me. You've been up longer,
That's
but
okay. No, you're good. Um, I don't know if I'm on the right track, but could you use cosine for the side angle side? Wait, yeah, yeah. Could we use the side angle side to like find that side because we
yes.
have this angle and that side. So I
Yes.
think we could use cosine.
Okay. So cosine of 115 or the 32.5?
Cosine of I don't think we'd
Would it,
use the 115. I would say use oh wait, yeah, no we do. Um yeah, the cosine of 115.
okay, so we're trying to solve for h, which I'm going to just call our hypotenuse in this instance.
Okay.
So would it be opposite over hypotenuse? But the opposite is its hypotenuse. Would it just be a 1-to-1 ratio?
Um what do you mean?
Well, for cosine, it's opposite over. No, it's adjacent over hypotenuse. Question is which adjacent?
I
The
don't know.
200 or the 300?
What I was doing, let's see,
Uh-huh.
is the small angle 32.5?
Yes.
Okay. So what I was starting to do is h over cosine 115
Mm-hmm.
equals um uh 200 over cosine of 32.5.
Okay, that makes a ton more sense.
Let's see what that is.
So h is equal to 200 cosine of 115 over cosine of 32.5. Oh, that is not the right calculator.
Okay. I got a negative number, so I don't know if it's right.
Hmm.
Was it supposed to be negative?
Let me try something really quickly.
Yeah, sure.
Okay, I think we were supposed to use sine instead of cosine
Okay.
since we had all that information. Because
Yeah.
if we do sine, we get 97.39 or 97.4 as a positive number.
Yeah. The answer key says, oh, I think we have our angle measures wrong.
Oh,
Or, well, so the answer key says that the magnitude of R is 425.1 pounds. And then that the measures of A and B are like those angles, like the interior and exterior angles, are different from what we have.
awesome. Okay, he's got the 115 written in there.
Yeah.
Oh. No, it should have been evenly split. I don't understand why he's saying it's not.
Here, I'll be back in just a moment.
That's fine.
Okay. Let's see.
Mm. Oh.
Um,
Nope. That is not the wait. Nope, still not the same number, so I don't know where they got that one from. I understand r squared should equal x squared plus y squared. Oh, we just have force. We don't have the. Yeah, that is the magnitude of the vector. So it would be 200 squared plus 300 squared is equal to r squared. Which but that's not the same. Where is he getting the 425.1 from?
I don't know.
It would be awesome if, he gave his answers. Or, I mean, it gives his answers, but it would be awesome if he showed his work like we're supposed to be doing.
Yeah. Yeah, that would be helpful.
well, we got the prep.
Yeah.
Okay. Do we want to go ahead and convert the following equations, or do you feel okay with that?
They're difficult, but I did those ones fine.
Okay.
What I have trouble is going from polar to Cartesian.
Okay.
But
The two formulas for that? I mean, we talked about
no,
the
like I
first
have
one.
the formulas, but it's just hard for me to like work out the steps, but I got them
Okay.
like in the preparation and stuff. So we're done with that one.
All right. I'm gonna have to close this for a second because he wants
Okay.
two separate videos.
Oh,
So we'll go
really?
ahead and
Okay.
yeah. So I'll go ahead and close this, start up the next one, and send you a link if that's cool. Then
Okay. Yeah.
stop
Thank